Hello, what up? Second video of our little trig unit. We're going to talk about finding sides of a triangle. You might say to yourself, well, we just did that. The first video is all about Pythagorean theorem and finding sides of a triangle. And that's true. You're not wrong. But we're going to do things a little differently, and we're going to find sides in different situations today. So our EQ is how can I use sine, cosine, and tangent to find missing sides of a triangle. Hopefully those words sound familiar. SOHCAHTOA, maybe you've heard of before. We'll talk about all that in just a second. Is a quick little warm-up. We're going to find the side length of this triangle. Now, because we do have the other two sides of the triangle, we are going to have to use Pythagorean theorem, or we can use Pythagorean theorem. Anytime you can, you probably should, because it makes life a lot easier, as far as it's much quicker than what we're about to do today. So here I've got a squared plus b squared equals c squared is what the Pythagorean theorem says. Remember, that works only in right triangles with the side lengths. I don't know side A, but side B is 15.2. Remember, A and B are interchangeable. The only thing that matters is that side C is the hypotenuse, which is across from the 90-degree angle, equals 19 squared. So I got a squared plus 15.2 squared, which I do not know what that is. 231.04 equals 361, which is 19 squared, which is not impressive because I messed that up in the previous video. I just remember it. So I'm going to take away 231.04 from both sides. That's hideous. Boop. So if I do 361 minus the answer, it's 129.96, and that's just equal to a squared. Then to get rid of a squared, or the inverse of squaring something, is to square root. So I'm going to square root 129.96 and get, nice, just 11.4. No rounding needed. So that missing side is exactly 11.4 long. 11.4. So that is Pythagorean theorem. That's how we find the third side of a right triangle if we know the other two sides. Before we get into the new stuff today, let's revisit what sine, cosine, and tangent are. It's not like a number, pi is 3.14. Sine isn't a set number. Sine is simply defined as a ratio, meaning a fraction, comparing two sides of a triangle. Sine, cosine, and tangent, all three of them are that. First of all, this symbol right here, you might see from time to time. This is the Greek symbol or Greek letter theta. This is often used to signify angles in trigonometry. But what's important is that this is an angle in degrees. Okay, so it's not a side length. If you see sine parentheses, what has to go next is an angle. So today we're going to be talking a lot about angles. But the sine of a given angle is defined as the length of the opposite leg divided by the hypotenuse. Okay, this is often shortened to just O divided by H, and that's where you get the SO in SOHCAHTOA. Okay, and again, if you forgot all this, we'll talk about it. Cosine, the cosine of an angle, is defined as the length of the adjacent leg. Adjacent means right next to, so we'll look at that in a minute, divided by the hypotenuse of the triangle. Good Lord. Hypotenuse. Again, this is often abbreviated A divided by H, which C cosine adjacent hypotenuse. And then finally, tangent. The tangent of an angle is defined as the opposite And when I say opposite, I mean the length of the opposite leg divided by the length of the adjacent leg, which again is shortened to O divided by A, which gives me tangent, opposite, adjacent. So then you have this whole, like, you've almost certainly heard SOHCAHTOA before. It's just a way to kind of remember which letters go with sine, cosine, tangent. I still use it to remember from time to time because sometimes it's tough to recall. But you don't need to see me highlighting anymore. So let's move on. Okay, so here's how this thing works. Okay, so in this right triangle, I have labeled the angles. Now, with sine, cosine, and tangent, you're never going to worry about the right angle because we know the right angle is 90 degrees. So you're always going to be working with one of the other two angles when we're doing this. Okay, and so in this, if I'm talking about, let's see if I can make this make sense. If I'm talking about angle X, okay, the side or the leg that is opposite of that angle is the one that's across from it, meaning it's not touching that angle. So when I'm talking about angle X, this would be the opposite. 5 is clearly the hypotenuse, and 4 would be the adjacent side because 4 is the leg that meets with the hypotenuse to make that angle. So adjacent means the leg that's right next to the angle. Okay. Now, here's the only, like, here's the biggest part that students get messed up. If I'm talking about instead angle W, okay, things change a little bit. Now the side that is opposite to the angle is the 4 down here. The 3 now is the adjacent leg, and the 5 is still the hypotenuse. Okay. So I'm going to actually leave these letters on there to show you how easy this can be when we're doing sine, cosine, tangent. Okay. So for the first, this right here, this first trigonometric, I'll call it a function. It's not really a function, but for this first part, you are being asked to find the sine of angle W is how you should read this. Okay. So angle W is in blue, and sine, if we look back at the previous slide, sine is opposite over hypotenuse. So all I have to do is put the length of the side that is opposite to W divided by the hypotenuse. Well, we knew the hypotenuse was 5, okay? And the side that is opposite to W is the blue O, which is 4, okay? So the sine of W is 4/5. That is all you have to do, okay? Now, we'll use this later on, but for right now, if you're asked what is sine of W, that just means take the opposite side length divided by the hypotenuse length. That's it, okay? If we go to the next one, what is tangent of X? Okay, well, X was denoted in red, and tangent is opposite over adjacent. Well, which side is opposite to angle X? Is the 3, right? Across from angle X, across from angle X is the 3, and adjacent to angle X is the 4. So 3 divided by 4. That is the tangent of X, okay? Now, if I want to do the same thing, cosine of X, so I'm still using angle X as my reference angle, but cosine is adjacent divided by hypotenuse. Well, we know that the hypotenuse is 5 in this triangle, but we also just saw that the adjacent side in terms of X is 4. So I'm going to put 4 here. So the cosine of X is equal to 4/5. Notice that's the same as the sine of W because you're referencing the same two sides, the 4 and the 5. And then finally, the cosine of W. So cosine was in blue, or sorry, angle W was in blue. Cosine is adjacent over hypotenuse. The adjacent side to W. So here's W. The adjacent side to that is the 3. So this is going to be 3 over 5. Okay. I'm going to move a little bit more quickly through the second one. I really wanted to break that first one down just to show you that it's not the end of the world to be asked for, I'm just going to do this right away. It's not the end of the world to be asked sine, cosine, tangent of things. Red will go here and there. So then in red, this is in red, according to Y, this is the opposite side, this is the adjacent side, and that's the hypotenuse. And in blue, according to angle Z, 5 is the opposite, 12 is the adjacent, and 13 is still a hypotenuse. Okay, so sine of Z, sine is OH, opposite over hypotenuse. So in this case, we have 5 over 13. My goodness gracious, what is happening? 5 over 13. Next one, what is the tangent of Y? Well, tangent is opposite over adjacent, and in red, that is 12 over 5. Now, I could write that as 2.4, but I'm just going to leave it 12 over 5 for now. The cosine of Z, cosine is adjacent over hypotenuse. I go back and look, that was 12 over 13. And then finally, tangent is opposite over adjacent. And I already have those two numbers from the first two Z questions. So that's going to be 5 over 12. Okay. Now, there's a lot of things that we could talk about and that were covered in geometry, just about how the two angles and their sines and cosines and their tangents are related to each other. But we're going to move on and just kind of utilize this relationship now to go from here. Okay, so here's what we're going to do now. Okay, if I want to find this side of a triangle, we could use Pythagorean theorem if I also knew this was like 10. If I knew that was 10, I could use Pythagorean theorem and go backwards. But I don't know what that the bottom leg of this triangle is, so I can't use Pythagorean theorem. So we're going to use sine, cosine, and tangent that we were just using, and here's how we're going to do it. Okay. In order to do this, you have to be given an angle. So we do have an angle of 51 degrees, which is referencing this upper angle up here. What I need to now do is label the 12 and the x as either opposite, adjacent, or hypotenuse. Okay. The x, if you want, you can label opposite because that's across from it. The hypotenuse is across from the 90-degree angle. So this is my hypotenuse, which means this is my adjacent. Okay. Now, the only thing I don't like about putting the O down there is that can confuse you. Opposite is not going to be part of this problem at all because I don't know the length of that side, and I don't care about it. So adjacent and hypotenuse tells me that I need to use cosine. Okay. Because the cosine is the of the three functions, cosine is the one that relates adjacent with hypotenuse. So what I'm going to do is I'm going to set up a little equation here. I'm going to set up the cosine of, and remember, what comes after cosine has to be an angle. So I have to put 51 in here. So cosine of 51 equals adjacent divided by hypotenuse, which in this case is x divided by 12. Okay. Now, what I'm going to do is, just like any equation that has a variable in it, I want to solve for x. I want to get x by itself. Right now, x is being divided by 12. So to get rid of or to undo dividing by 12, I'm going to multiply by 12, which would cancel those out. But I need to also multiply the left-hand side by 12. Sorry for the noise. So now what I have is 12 times the cosine of 51 equals x. Now, every angle has a unique cosine decimal that goes with it, or a cosine. So the cosine of 51 is a specific number. So we're going to just type it in the calculator to do this. The first thing you need to do is you need to make sure that your calculator is in what's called degrees mode, because there's two different ways to measure an angle. We're not going to get into that today. If you're using a TI calculator, find the mode button. And on mine, it is the fourth line down. Right now it says radian, which is the other measurement. You need to go over to degree, click enter, so that degree has the black blinking box on it. And now I'm ready to do the work that I need to do, okay? If you have another calculator, sometimes there's just a DRG button that you hit, which are degree radians, and then there's another one as well. But on most TI calculators, if you hit the mode button, you can go over to degrees. Now I'm going to quit, which is in right above mode, so second mode. Now I'm going to type in 12 times cosine, sine, and tangent are all right above the parentheses. So cosine, and then the angle that I'm given is 51. Then I'm going to close off the parentheses and hit enter. Now that is the length of side X, okay? Again, we're going to, as far as rounding goes, most of the time with sides, you would round to the hundredths place. But I don't want to say most of the time because it depends on what situation. I'm just going to round to the hundredths. So 7.551 would round to 7.55. That is the length of the missing side. Okay. So this side up here is no longer unknown. It is 7.55. Now I could use Pythagorean theorem to find the third side of that triangle, but I do not care to find that right now. So we're going to move on. All right, same idea. Okay, we have an angle, we have a side, and we have a side that is unknown but is marked with a variable. So here's my angle 48, which is down here. So if I'm going to label these things, this is my opposite side. There's the hypotenuse, which means this is the adjacent. Okay. Now, again, I don't care about the hypotenuse in this problem, so I'm going to get rid of it. So I want opposite and adjacent. And if I go back here, if I scroll back, the trig function that uses opposite and adjacent is tangent. So that means for this problem, I'm going to be using the tangent of the angle that I'm given. So what I'm going to do is I'm going to set up tangent of 48, which is the angle, equals opposite over adjacent, which is x. Okay. Now, mathematically, if I want to get rid of, my goal is to get x by itself. Okay. There's a couple ways to do this. There's some shortcuts, but if I want to get rid of a denominator, even if it's the variable that I care about, just like in the last problem, I multiplied both sides by 12. Here, I'm going to go ahead and multiply both sides by x. What that'll do is that'll get rid of the x over there, and now I no longer have a fraction. I just have an equation that's all in one line, which is great. Okay, and now to get x by itself, I need to get rid of this tan 48 thing. But again, each sine, cosine, tangent of any angle, like this right here, is just a single number. It's something that's stored in the calculator. So I can divide, and I know this looks weird, I can divide by tan 48. I can do this to both sides. That cancels there. So here I get 8.3 divided by tan 48. Okay. I'm going to type it in the calculator exactly as that looks, divided by tangent of 48. Again, you will get, every answer will be wrong if you don't change this to degrees mode first. So I'm going to go 7.47. Again, if I'm going to continue rounding to the hundredths place. So it tells me this side of the triangle is 7.47. Okay. And finally, one last one just to wrap this up. Here I'm trying to find the hypotenuse. So my angle is 79. I have the opposite, which is 24, and I'm trying to find the hypotenuse. So I'm going to use sine. So I have sine of the angle. It's a lot of road work going on right now. Is opposite over a hypotenuse. So again, here I have to, just like in the previous problem, I have to multiply both sides by x. So I would have x times sine of the angle equals 24. And then I'm going to divide both sides by sine. And so now in the calculator, I'm going to type 24 divided by sine of 79, and I will get the unknown length of that angle. And it's 24 point. Now, if I'm rounding to the hundredths place, 0.449 would round to 0.45. So 24.45 is my missing side there. 24.45. Okay. So that's how to find the missing side if you don't have both the other sides. So how can I use sine, cosine, and tangent to find missing sides of an angle? So we have SOHCAHTOA. We have to choose the correct trig function. We need to set up an equation involving x. Oh boy. I apologize for my horrid handwriting, but I'm getting old. It's not going to change now. And then finally, I need to solve for x. And that'll do it.